Hi, Integrated Math 1. Welcome to lesson 5.2.3a. We're doing day 1 of reflections as functions. So last couple days we were looking at our translations, our slides, and how we could write them in function form and use the function form, all that cool stuff. We're now going to do the same thing with reflections. As we go into this, you are of course going to want a straight edge compass. You're going to want a straight edge, probably a compass as well. I would recommend those things. Of course, your workbook and a pencil, always useful. So just a reminder that a reflection is when we flip our figure over a line, and we'll get a little deeper into the definition on that today. So we're going to represent reflections in the plane using constructions. We may or may not get to the patty paper, but we'll definitely use constructions. We'll describe reflection transformations as functions that take points as inputs and outputs are reflected points, right? We'll identify reflections as points that are equidistant to the perpendicular bisector of line segments, connecting that pre-image and image points. And if that sounds confusing, don't panic, we'll get there. And specify a sequence of translations and reflections that will carry a figure onto a congruent figure. These are our goals for this lesson and the next. So we are going to be using key terms like reflection. We are going to talk about the perpendicular bisector theorem. We've made those before. We're going to talk about what that theorem is. We're going to talk about what a theorem is and what a proof is. That will eventually come around. So you have learned how to represent a horizontal or vertical reflection of a function, right? You have a line, that's your line of reflection. You flip it over to make your reflection. So how can you write geometric reflections of figures on the plane as functions, right? We like using that f of x. Last time we were doing that capital T of whatever that was that we were flipping over. So how would we do that as a reflection? So in the previous lessons in the last unit, we were constructing perpendicular bisectors, right? They're really easy to do. So if you're on page 80 of your workbook, I would like you to take your straight edge and compass and start off just by going ahead and constructing a perpendicular bisector of this line segment RB. Go ahead, hit pause to work that out, hit play when you're ready to check your work. So real quick, I'm going to bring up my camera. There it is. There we go. So here I have my lovely camera because here I have the same page in front of me that you have in front of you. Now we talked in order to do a perpendicular bisector, we've done this many times before, you want to make sure that you put the stabby guy on one point and that your pencil is more than halfway, right? That was our deal. Pencil needed to be more than halfway, and then we just made a big arc. And then we did a matching one on the other side. So I put my stabby guy on R now, and I'm just going to do a big arc. I can do this. There we go. And of course, now I have a point where they hit above the segment, a point where they hit below the segment. And I can totally just, make a line right through. And you have constructed the perpendicular bisector of segment RB. Hooray! That was very exciting. You've done this a million times before. Y'all were killing it. So that shouldn't have been too bad. Now, I'm not going to ask you to trace this onto patty paper because I know not everybody has patty paper, and that's okay. But can you do this in your head? If I were to fold along my perpendicular bisector, if I were to fold this along the perpendicular bisector, what would happen with R and B and what transformation would go on there? Hit pause, jot down your thoughts, hit play when you're ready to check your work. So I noticed that if I folded the paper along this perpendicular bisector we made, the R and B would end up right on top of each other. So I can fold the paper along the perpendicular bisector to map B onto R, but what that means is that B and R are reflections of each other, right? If I can fold it to flip it to the other side, they are reflections across that perpendicular bisector, right? Right. So this is the idea. If we're doing reflections, I can literally fold it and it would be right on top of itself. We're just flipping it over. So you've seen in previous lessons, the last lessons we did, how you can do translations in web design, right? How you can be like, I'm going to make this arrow like fly across the screen. And they're often written as functions, which takes points, distances, and angles as inputs, and it outputs a new set of points after applying that transformation. Well, just like we did that for translations, the same is true for reflections. So we're going to do this here again. We have a little bit of web design going on. To reveal a message during the game, you have to make the two triangles fly open. So you have to be like, boop, boop. You got to open them up in order to see those. So let's see how we can do this. So I'd like you to consider the reflection of triangle FJD across line M. Can you just pause and take a moment to label the points of the new image? Instead of F, it'll be F prime. Instead of J, J prime. Instead of D, D prime. Go ahead, hit pause, write it out, hit play when you're ready to check your work. So when I fold along line M and I flip this guy over here, this point, instead of being F, becomes F prime. This point, boop, becomes J prime. And this point, whoop, when I flip it over, becomes D prime. Awesome. So what is the relationship? What relationship there is among the line segment J to J prime and D to D prime? So if we were, I'm going to grab my pen here. If we were to draw a line segment going from J to J prime, I guess J to J prime, and another line segment D to D prime, boom. What's the relationship between these two line segments, J to J prime, D to D prime? Hit pause, write down your thoughts. There may be a pattern going on here, and then hit play when you're ready to check your work. So I don't know about you guys, but I noticed this line segment, J to J prime, and this line segment, D to D prime, they're parallel. Of course they're parallel. We're not surprised by that at all. So what's the relationship then from those two line segments? I'm going to draw them back in again. So J to J prime, and we said D to D prime. Sorry, I'm drawing it worse than I did last time. We said those guys are parallel. What's the relationship with these guys and line M, our line of reflection that we were flipping over? Go ahead, hit pause, jot down your thoughts, and then hit play when you're ready to check your work. I noticed two things. Like I noticed that M goes through the midpoint of J to J prime and the midpoint of D to D prime. Did you catch that? That line M hits the midpoint of those segments. The other thing I noticed is that they were perpendicular. You probably noticed the perpendicular thing. I'm sure you noticed the perpendicular thing. So what this means then, since points on line M are midpoints of each of these segments, and line M is perpendicular to the segments, guys, line M, and this is the big one here, maybe I'll even highlight it, line M is the perpendicular bisector of the segments. Yeah, line M is the perpendicular bisector that connects your pre-image and your image points. That's interesting, isn't it? Because we were just playing with perpendicular bisectors, right? So we're seeing that my line of reflection is the perpendicular bisector of the segment between the pre-image and the image. So it goes through the middle and it's perpendicular. That's super interesting to notice because we were already learning about perpendicular bisectors. So of course, you already know this is a reflection. So we can write reflections as functions. We use a capital R for reflection. And then this little lowercase guy, this little subscript, that's our line. So, and of course, we have an input P of some kind, the location of a point with respect to some line of reflection L. And of course, it's opposite the location of P with respect to the line of the reflection. This sounds complicated, but here's the deal. We use a capital R for reflection. We're doing a reflection. So for my function, I'm going to use a capital R. I'm going to put the line of reflection as a little subscript down there. And then, of course, I'm going to input my point and then equal to whatever my output is. So we did this a little bit the other day with translations. Now we're just using a capital R and we're using the line of reflection to do our reflection functions. So can you please, looking back at question 1, what we just did, can you write a function of the form R sub L of P to describe the reflection of triangle FJD? Hit pause, see what you can do, and then hit play when you're ready to check your work. I'm going to scroll back here just for a minute just so I can see things. I'm going to do this just so I can see stuff. And I'm going to erase some things. So I'm back on question 1 here. So real quick, I know you're writing it on a different part, but I need to see it to know what I'm doing. So we're saying it's a reflection, so capital R, over line M, so a little subscript M, little baby M, except I can't get my baby M to write nice. I'll work on that. Baby M. There we go, that's better. Now I'm inputting my triangle FJD. So I'm going to say the input is triangle FJD. And it equals, well, if I input a triangle, I got a triangle as my output, right? So I'm going to say my output is triangle. Now it's F prime, J prime, D prime. So F prime, J prime, D prime. Beautiful, beautiful. Did you notice, by the way, that my reflection is congruent to my original? Did you catch that? I mean, yeah, we flipped it, but I kept the size and the shape the same. Guys, a reflection is an isometry. We learned about that word, right? We learned about that word last time. An isometry. Yeah, a reflection is just an isometry. It is. Kept the same size, kept the same shape. Isometry it shall be. All right, then. Very nice. So now knowing what you know that the distance on one side is equal to the distance of the other, right? My line of reflection goes to the midpoint. You know it's perpendicular, all that good stuff. I would like you to go over to page 82, and I would like you to complete the reflection for A, for my lovely parallelogram STUV. Can you go ahead and complete the reflection using each one? I've got A, I've got B, I got a couple. How many of these do I have? I have A and B. So watch out. A is on the bottom of page 82. B is on the top of page 83. Go ahead and do both of these reflections using the given function. Hit pause to work these out. Hit play when you're ready to check your work. All right, so here's what I'm going to do. I'm going to come over to my camera so that you can see my paper. Makes things easier. There's my paper. It's fuzzy. You're going to focus up for me, baby? Maybe. Oh, better. Yes. Okay. I'm going to use my straight edge. I'm going to use my compass. Now, we said that the line is perpendicular and it's going to go through the middle. So you know what? This looks pretty perpendicular to me. I could go all out and use like make a perpendicular bisector, but I'm not going to. I'm going to just kind of make a big old long dashed line. I'm going to make it way too long. I'm going to come over here. I'm going to do the same thing here. I'm going to make a long old dashed line. I'm going to make it way too long, and I'm going to do that on purpose. There we go. So I'm deliberately making them way too long, much longer than I need them to be. And here's what I'm going to do. We said that this should be the midpoint, right? Sorry, my computer's kind of in the way here. We said this should be the midpoint. So fine, I'm going to use my compass and I'm going to be like stabby side, and I'm going to adjust. I'm going to reflect point T first. I'm going to reflect point T, so stabby side and pencil side. And I'm like, well, that's how long it is. So I'm going to flip around. Remember, it's a flip, and I'm going to put it on the other side. And I'm like, all right, cool. That is where T prime should be. And then I'm going to do it again, only I'm going to reflect S now. I'm going to be like, all right, cool. I'm going to put the stabby side here. I'm going to put the pencil side over here. And I'd be like, all right, that's how far it is. I'm going to flip around. I'm going to make another mark. And I'm like, cool, that's where S prime is. Yay. I'm going to do it again for you. I'm going to do it for all 4 of these. I'm going to do it for you. I'm going to do it for V. So again, stabby side goes on the line in the middle. I'm going to adjust my pencil so that it touches you. And then I'm going to flip around and put it on the other side. Notice how I'm labeling as I go. I'm also making my marks nice and obvious. I'm going to be like, that's U prime. And then I'm going to do it one more time. Stabby guy in the middle. Adjust my pencil to get all the way over to V. There it is. And I'm going to come around, flip around, make a nice little mark, and be like, there you are, baby. There's V prime. And then I'll go ahead and I'll connect up my lines. So this is going to be real helpful for your homework in case you haven't already figured that out. And there you go. Ha ha, you just made it. Look, there it is. It's so pretty. How'd you do with this one? If you need another minute, now that you've got the idea, it's cool, it's cool. If you need another minute, you can hit pause and work it out. But I'm going to go ahead and come to my camera and work my way through it just like we did, except I went too far. There we go. All right, I'm going to come over to the top of page 83. And let's see what I got going on here. Again, it's fuzzy. Come on, baby, you can do it. Good job. Good job. Sweet. Again, I want to be, if I'm going to move point J and even T and G, we want to go perpendicular to the line here, right? Perpendicular to my line of reflection. And I'm going to deliberately make it way too long. Doing that on purpose. I'm going to do that again with G. Now, again, this one's more of an estimate, I guess. But again, I'm going to make it way too long, and I'm going to do that on purpose. And then I'm just going to use my compass. I'm just going to measure things out. So that's the middle. That's the middle. So this should be the middle. So stabby guy in the middle, pencil guy on J. There we go. And then I'm just going to turn it, make a little mark, except I didn't do a good job. Pretend like I did. So there's J prime. Again, put my stabby guy in the middle. I'm going to move my pencil so that it touches T. Exactly. I can do it. Boom. There it is. So there's that distance. Sweet. I'm going to come over here. Make another little mark. Woo, barely made it on the paper, but hey, it made it on the paper. That's what matters. So that's now T prime. And last but not least, I'm going to go from the center here and I'm going to adjust my pencil so that it touches G. So there's my distance. I'm going to flip it around, make a little mark. It's not perfect, but we get the idea. And that is now G prime. My mark is not very good. I'm going to make a better mark. Maybe I'll make a better mark if my pencil will play nice. My pencil doesn't want to play nice today. That's okay. And then I'm going to use my straight edge and I'm going to connect them back up from a new triangle. New triangle. New triangle. Ooh, look how pretty that is. Oh my gosh, it's beautiful. Yay. Good job, guys. As always, I hope you found this helpful. I hope you found this useful. You got questions or concerns? Come talk to me. I'm around, and I'll see you guys soon. Bye.